Okay, this is the third and final presentation about risk management, safety, and liability, and it's going to be some overall design concepts of safety. It's come up that some people like to have their safety tests done through the network. They create the tests online, which is great. This kind of things are always harder to set up than you think they're going to be, but once it's done, it's pretty easy. And that's, if you like doing it that way, great. There's also companies that sell the services of providing safety tests for students, and some districts will pay for that. I'm not real fond of those. And the reason is you can bet that that vendor's going to be doing exactly the same thing you should be doing, and that's covering their ass. They have a bandsaw test, and they talk about a 16-inch bandsaw, but yours is 12 inches. So if something happens, they're going to say, well, it's your responsibility to explain the differences of the different size bandsaws. You weren't using the bandsaw that we tested them on. Even though there's not much difference, they're going to find a way to make sure that they're not liable. And I've seen some places use them. They're a little bit more cumbersome for the teacher to coordinate these things. Quite frankly, the paper and pencil Scantron style test that has proven useful over the years is really pretty simple to administer. Okay, this little diagram shows how OSHA sees safety. Even though they primarily are workplace, worrying about safety in the workplace, it also applies to schools. And you can see the most effective is elimination, going to substitution, going into engineering controls, administrative controls, and then down to personal protective equipment. This can apply to explain how this applies in the school and how you can design your safety program around this. Okay, the top part, elimination. And I was just asking to make sure, does this thing need to really be done? And they're asking, is it necessary? And I've used an example here of leather working as a class. I'm not sure of anywhere in the state that processing leather is done and would be considered a career technical education program, but there may be a place where it's still taught because 30 years ago it was viable. And so getting into the hazardous chemicals or the processes for doing that, it may be worth dropping that class from the catalog. So you need to be able to make a case for what you're doing is necessary to move forward the curriculum. And that goes back to the class outcomes. And if there's a hazardous operation, does this meet the outcomes, the goals, the objectives of the class? And if it does, yeah, you can't eliminate that. Okay, going down the pyramid, substitution. And if you've made the case that some particular operation is necessary in your class, can you substitute something for that? And not only the process, but the materials. But with the process, it could be, if you're doing want to demonstrate casting. Well, aluminum casting is very involved. You got to have ovens, you're pouring molten metal. It's fairly hazardous. But casting plastics is relatively safe. So, can you substitute a different process? And in this case, I was substituting material. And you might want to think that in your class, and your project lead the way, people have provided you with a small CNC, and you want to do something with milling. Well, you can mill plastics instead of steel. Would it be the same value? Yeah, pretty much. UHMW polyethylene machines quite nicely, and you don't have the coolant problems, you don't have metal chips, and they'll still see what CNC manufacturing and chip removal is like, but with something much safer. So think about substituting materials, think about substituting processes that can give the same educational benefit. Moving down the pyramid again, we're now talking about engineering controls. And this is mainly guards. You got them, use them. And be sure that you show good practice and use them when you're using them. It's possible that during a demonstration you got to remove a guard just to show something, but when you're doing your own work or cutting something for another student or a teacher, make sure those guards are in place when you're using the machines. And I don't think it's possible for a school not to get a table saw that's a stop saw. It's one that it stops if it comes in contact with flesh, so you just get a little scrape instead of cutting fingers off. But try to make sure that the safest equipment is purchased. And one of the things I'm seeing happening is that a lot of shop equipment was pushed into a storage room, and now that the STEM programs are out there, they're being brought out, and here's some 10-year-old equipment, which is still quite functional. But they don't have guards anymore. Well, you might need to build them. You may need to have somebody set up something to make it work. Most of these things can be retrofitted. And so try to make a effort that proper guards are in place from shears and saws and the like. There's also a part of this engineering control that is access control, and that's the yellow lines around the work area around machinery. You've probably gathered from the previous presentations I'm not that fond of those things. I was in a shop recently that had clearly been remodeled many times, and every time they put a new yellow zone around wherever they placed the machine before, and the floor was just basically a grid of yellow lines, most being irrelevant. Well, in that case, it can be overdone. But this can also be access control of circuit breakers that are turned off so that students can't use certain machines, and the instructor is the one that has access to it. So there are plenty of ways to make sure that you can control access. The fourth level is administrative controls, and this is standard operating procedures. In our case, it's the class policies and protocols. Have a standard way for a student to log onto their computers, and if they log on differently or under somebody else's name or some other way, and then they get involved in cyberbullying, you at least can be able to say this person was not following class protocol. And it's still good practice to have students who are operating machines be the only person in the operational area, even without the yellow lines. But whatever your protocols are, you need to make sure that you do enforce them. And most importantly, in this administrative controls, in industry, it would be certification. A person can't drive a forklift unless they're certified or checked out on forklift operation. Well, for us, it's the safety test. These tests are essentially the certification that that student is able to use that piece of equipment. And so at the high school level, be sure you give a test on each hazardous machine, and very importantly, keep records. The fifth level and least effective is the personal protection equipment. Be sure to, make sure they wear the safety glasses and tie back long hair and no sandals and that kind of stuff. But think of safety gear as the last line of defense, not the first. And it's a good way to present this to the students that they need to perform a mental checklist of things before they operate the machines, that the fences are in place, the materials locked down, whatever, before they actually run the machine, and that the final thing is the safety glasses. Now, they probably should have already been wearing them, but you could say, now put on your safety glasses once you're ready to go to work. Do it that way mentally. The sixth level, okay, there was no sixth level, but there are some other considerations with this. Biochemicals. You may be involved in something doing some biochemical stuff. And general safety stuff, lighting, fire extinguishers, exits, noise, that kind of thing. Just general things that you need to take into account. And even in the classes that are heavy on computer design, that type of stuff, you're still going to have, hopefully they're not just sitting in front of a computer for the entire semester. Hopefully they're building little models of what they're doing or other stuff. And you've got to be careful. Glue guns can be hot. Screwdrivers can cause injuries. There are things that just need to look at from a general safety point of view. And if you're building a new lab, and there are a lot of places that are actually building new labs these days, that's kind of beyond the scope of this course. Back when I got my credential, we had to actually take an entire 3-unit course in designing, in shop design. I've forgotten most of it, but I can point you in the right direction to find some things. You're probably going to be limited because the construction companies want to put the electrical drops in certain places. But if you're lucky enough to have some input into it, think about how it's going to work and think about it for safety and education. Okay, you've now heard a whole bunch about safety and how teachers have been approaching it for a lot of years. If you make sure that you have done your job for safety, the students will be safe. In other words, covering yourself against liability will ensure that the students are covered against injury. And fear is really okay. Students should be scared the first time they operate a machine, the first time they strike a welding arc. But the chance of a possible injury really shouldn't get in the way of students' willingness to learn. They want to do things with their hands. They want to build things, and their shops were closed not because they couldn't find teachers. They didn't bother looking for teachers because the new principal had been a primary school teacher and was scared of the children getting hurt. Keep in mind, these are 16, 17, 18-year-olds who want to experience life. They need to be treated like adults. Officially not adults till they're 18, but they're not 6-year-olds. And one other thing about this is for future engineers, this time in high school, a shop class like this might be the only time they get to run machinery. The School of Engineering is right next to our department, and a lot of their students come and take our classes because ours are hands-on, because they know that they will not be doing hands-on work in, they don't get to run machines. So life's full of dangers. School shop accidents are rare. Auto accidents are more common, but you drive to school, you're taking more hazards driving to school than you are working in your shop at school.